Okay, a lot of people enjoyed the Shatter tutorial, so I thought maybe I would do another one because I like playing with geometry nodes. And this time we're going to look at a rope. You're going to be able to unravel this rope, change the amount of segments, and get as detailed as you want with it. Okay, so this will be a Blender 3.1 tutorial. It's just way easier to do this in 3.1. And right off the bat, Shift A to spawn in a curve and then set a Bezier curve. I'm going to rotate this 90 degrees and apply the rotation with Ctrl A, just so everything is zeroed out. Then I will go into my geometry node setup, but all you need to do is pull out a Junctional Editor anywhere, that's what we're looking at, and just click New, which will just set up a geometry node for us. So the first thing we want to do is we want to duplicate this initial curve, so we have other curves going around it. We're going to do that with instance on points and make sure the input goes into the instance socket. But also I want to be able to view it after it has been copied, so I'm going to plug it into the end using a join geometry. Okay, so we need points to instance this on. I'm going to use a mesh line, since if you set the offset of mesh line to 0, all of its points will spawn at the world center, and then our count is just the number of points we're going to use. And over here I will stop and I will group all of this up, because I know that later on I would like this to be a single group which takes in a curve and spits out other curves that are coiling around us. This will let us do sort of a procedural effect. We'll be able to just keep going, keep subdividing the curves, etc. So I'm going to name this input so I know what we're dealing with, curve. Also the output, curve. The first thing we're gonna want to do is realize these instances. So Shift A, realize instances, so that we're not working with just instances but the curves themselves. And we're going to want to push these curves away, because currently we have 10 curves that are overlapping. In fact, we're gonna want to have a control here, so click the plus, name this one count, make sure it's an integer that has a minimum value of 0 and a default of 1. Connect count here, and now we can control the number. We also want to be able to control it from outside, from our geometry nodes tab in the modifiers. So another control just like that, called count. This will just be the number of, well, ropes. It's going to be ropes eventually. So I'm just setting up some controls here. This will make it easier for us later on. And you can name this something like coil spline, because that's what it's going to do. It's going to coil a bunch of splines on the original spline. Okay, now we have a control for count. Realize the instances. What we need to do is push these along the normal, because this curve actually has normals. I'm going to the orthographic view. I'll draw these out. This is what the normal looks like. It's just a vector pointing away at all times, and we also have the tangent. Right? Tangent also a vector that's pointing towards the line. Hope that makes sense. And now we're gonna just hit them with the set position to move our handles, and then we're going to do normal. So if I plug this in, we should immediately see the line moving away. There it is. We just moved all 3 of these points that are overlapping away from our original points. And we also want to rotate, because if we rotate this normal around the tangent, essentially achieving this effect, where we're rotating our normal around the tangent, we will be able to coil this. Okay, so get a vector rotate, and we're going to be rotating the normal around the tangent. So grab a tangent node, plug that into the axis. This is the tangent, the vector it's rotating around. And now if I just change the angle, we should see that we're rotating around our initial curve. Of course, we want to be rotating more and more as we get towards the end. For that, we will use the spline parameter. Okay, so the spline parameter has a length and a factor node. The factor node returns for each spline inside our curve a value of 0 to 1, while the length returns a value from 0 to whatever the length is. In this case, it will be close to 2 meters. And I need to make a distinction here what comes out of this instance is a curve. So this would be the curve object, and the curve object has multiple splines inside it. That makes sense. So that's why this is called spline parameter, right? So let's just go ahead and do that. All we really have to do is take our length, run it through a math node. This math node is set to multiply, and now we can see that we are indeed moving the last point. However, we only have 2 points right now. To fix that, we want to resample our initial curve, because if you're going to edit mode, you see it only has 2 points. That's not enough to really coil around. Give me a second to delete the doodles. And where we're going to resample is outside of this node. Over here, before we go into our nodes for the coiling, we're going to do resample. And we're going to resample based on length. Pick something small, like 0.01. And I'm going to leave this for now. Later on, we will be adding a control for that. I'll keep it like this. And we will notice there's a bunch of kinks along the length. That is because of the way Blender previews now curves. You see resolution preview over here inside the object data properties. We're gonna max that out at 64, and it's gonna smooth it out. Next, the curve's a bit too big, so I'm going to add a control for the radius. The control for the radius will be simply a modifier after the vector rotate. It will be another vector math. We're going to modify it by multiplying it by some value. There we go. That's the radius. And I want a group input to control that. For that radius, it should be a float. Let me bring out the group node. Shift D to duplicate, plug that in. And in much the same way, I will add a control. I mean, we might as well add a control for the resolution right here. It will just be a float. Minimum value 0.01. We don't want this to get too low, otherwise it starts to chug a little bit. The default should also be decently high value. Plug that in. And now how are we actually going to name all these curves? To keep track of them, we're gonna have the initial curve, we're gonna call that T1. Everything around that tier 2. T is for tier. That's my logic. You can name it whatever you want. And then curves around the second curve is gonna be tier 3. So over here, what we're going to be adjusting is the tier 2 radius. Let's have it start off with 1, with a default of 1. I mean minimum 1, default 1. And let's just connect that to radius. If I now have it in the modifiers, I can adjust it from here. And in much the same way, resolution is a bit too much right now. Okay. And in much the same way, we want to control for the rotation, for the coiling. Add one, T2 rotation. Add one to the actual node that contains our coiling splines. And the rotation is simply a value that plugs into this multiplier here. Now I should be able to control that as soon as I connect that. Yeah, so now we can control the coiling and the radius and the resolution. Let me just save this real quickly. Okay. Next up, we have 3 curves here, but they're all overlapping. So how would we fix that? First off, let me iron this out because it will be a bit better. This is now a straight line, and if I see from the orthographic view, you're gonna see it's actually just a sinoid wave. So a little thing about those is that the distance between 2 peaks is actually 2 pi. And if we know this distance and we know the number of curves here, then we have to shift every curve by an amount that is equal to 2 pi over the number of curves. Does that make sense? So let me clean this up. Alright, so to do that, first off, how are we going to shift this? Shift all these curves along their wave. We're going to add another math node. Set this to add, and you can see as I'm changing this value, it's kind of shifting things, but we want each curve shifted by a different specific amount. Like we said, 2 pi over the number of curves. So we need to index them in a special way, and we're going to use a capture attribute to do that. So the capture attribute node actually stores an attribute inside the geometry itself. When I put this behind the realized instances, set it to instance, set it to integer, and add an index node to it, what this does is, by default, instance points actually gives us a bunch of instances which are just labeled 0, 1, 2, that's their index. And only once we do realize instances does the geometry node actually look at them as separate splines. Okay? And we want to embed this value of 0 to every point of our spline. And essentially that's what the capture attribute node does. And now we have this indexing coming out of this socket. So all we need to do then, let me just grab my nodes a little bit, is add another map node, set this one to divide. Like we said, just type in 2 pi, and at the bottom we need the number of curves. We have that from over here, count, and we need to multiply this value by this index. So I'm going to copy this multiply node, and now if I connect this, fingers crossed, there we go. Now they're all offset as much as they need to be. If I change the count, we'll see that they kind of sort themselves out. So this works with any count. I'll leave that at 3. And at this point I would collapse all of these into a single group that has to do with the rotation of the curve. Before I do that, there's a little tip here. You can take this rotation and replace it here, just so we have a single group input. This makes it easier after we group things. Control G. Now they're grouped, and I'll be naming these count. I'll call this big index, and then rotation. Okay, count, big I for big index, and then rotation. Cool. Rename this node to rotation because that's what it handles. At this point, you are pretty much done if all you wanted to get at is a rope, because if we just hop out of this, what we can do, as soon as I give me a second here to leave this. So what we can do now is we can just duplicate this node, plug that in here, join this so we still see that, change the count to 3, the radius to something decent, the rotation to something huge, and now we see that we have splines around the other splines. And we can do this as much as we want, although we will need to change the resolution. I'll just bump that up a little bit. Well, I need to change the minimal amount here. Set the minimum to 0.1, and then I can subdivide it further. Maybe even some more. And now they're really taking shape. All I would need to do then is run all of this through a curve to mesh after the join geometry, and put here a circle, curved circle. I'm gonna set the resolution of that to something like 8. It doesn't need to be too big. Adjust the radius, and yeah, so now you can get something like a rope. Currently it's more of a phone cord. I think it is too coiled up at the start. So you can adjust that with the rotation. Yeah, and then you can change the count, rather the radius of these ones. Slowly though. Hold shift to shift things more slowly. This is also a way to rotate it, something like 25. And really you can just start playing around with this. There we go, that's more like a rope, I would say. So if you really wanted to rope, probably stop here, although I will also show you how to do the unwind, and then how to do UVs, and how to instance some straight particles on that so that it looks better as well. So about the unwind, well, first off, let me just create some connections here because I want to control the second set of coils from my modifiers tab. So, alright, so now we have control for that too. Go ahead and go into one of these nodes, And to do the unravel effect, we're going to first push all of these splines away as they near the end. So we're going to be working in this area after the vector rotate. Now what we need to do is add another node before that. This is going to be another vector map. Oh, I'm sorry, it's going to be a regular map node. And we want to change the radius with some add value. So as we're getting closer to the end, we're adding more. I'm now going to group these two because I know this will handle the push, or rather the unravel, as we get closer to the end. And the way I'm going to be controlling the unravel is with a vector. So this would be unravel, and I'm simply using a vector because it lets me store 3 parameters that are all related to one thing. You can use separate floats if you want, but this is just what I pick. So here are parameters, and we need to talk about how this is actually going to happen. The first thing we need to talk about is the 2 lengths. So if I go curve length, spline length, and I also go spline parameter, you see that both of these nodes actually have a length attribute, but this attribute is different. So the spline parameter, if I have a spline here, it will give me a value 0 to 2 meters, like we said. So the middle would be like 1 meter. But the spline length would actually give me a value of 2 all the time. For each one of these it would be 2 because it just gives me the total length of the spline. It's not a parameter. And the same for the factor. The factor actually gives us 0 to 1, and the factor would be 0 to 5 here. So what do we actually want to do? We want to pick an arbitrary point from the end that's like, I don't know, 0.5 for example meters away over here, and this is where we want to start to unravel. To do that, we need to remap this area. Instead of it being from, currently it would be 1.5 meters, right, to 2 meters. We want to remap that 0 to 1. I don't have space here anymore, 0 to 1. And then the 0 to 1 value is what we're going to be adding to this node here. Alright? I hope that makes sense. I'm going to clean this now, and we're going to do it with nodes. The first node we're going to use is map range. And we're going to plug into the map range node the spline factor, the length. Make sure clamp is on. Then we're going to add a map node, set this one to subtract, connect the length to the first socket, and also connect the length to the maximum and the output of this to the minimum. And pretty much done. If I now plug this into here, first off, it is very strong, so I'm going to lower it by lowering the maximum. You can see this is my cutoff from the end. If I increase that, as we're getting closer, things are getting pushed. I'm actually going to reduce the count of tier 3. There we go. Yep, so I can now adjust where the unravel starts as well as the strength of the unravel, but it's very linear. To fix that, you will see that if I have a linear function like y equals x, if I just give this a power, that will allow me to just kind of change it so it's more smooth, it tapers off more. Right? Technically we're looking at this area here, it tapers off as I increase it. So to do that, right before the add node, we're going to hit them with a mat set to power, and you can pick the power yourself, usually something big like 3, and then compensate that by increasing the radius here. Now we're getting a really cool unravel effect. I'm going to increase the rotation so you can see it a bit better. Double that. Yeah, cool. So yeah, you can play with this exponent. To control all of this, like I said, we're going to be using a vector just because it's more convenient for me. You don't have to. So to do that, separate XYZ. Oh, that's RGB. Separate XYZ. Take the unravel vector. The X is going to control our cutoff start. The Y is going to control the strength. So the strength, as we said, is the value of the map range, the bottom value. Go ahead and hook that up. And of course I need to hook this up inside to our modifier. So I need to add a value for that. This will be tier 2 unravel, which would be a vector. the unravel goes into, oh, I need to add a node in here as well. Unravel, that is a vector. Plug that in, plug this in, and now from over here I can control the offset, and I can control the strength of the push. There we go. There we go. And in order to actually achieve the unravel effect, after the, or rather, yeah, after the resample, we need to actually trim this curve. So the trim node in here, and as we change this, we'll see that we're unraveling very smoothly. Nice. So a control for this, of course, right here. This is technically tier 1, so call it T1 length. Float that goes from 0 to 1 and the default value of 1. That's what it should be set to. I'll hide this real quickly. And yeah, now I have control over here. So that's cool and all, but the problem is that our curves are not rotating. Currently they're just getting pushed out, but we also want to change the rotation for it to look like a better unravel effect. To do that, we're going to be working on this area inside the rotation node that we created, and I'm going to straight up give it the unravel as a vector, because we're going to need that. And what we have to do is pretty much like the same, the push thing, except that we have to be working before we add the offset, because remember, this is our offset, this is our multiple. What we want to change in reality is the incoming radius, the incoming rotation. So to be fair, what we need to change is over here, the rotation. So go ahead and plug in a map node, map range again, length, spline length, again parameter, spline parameter. Plug the what was the length to maximum, and the spline parameter has to go through a map node, subtract, and over here we will plug in the vectors, so separate x, y, z. We're doing the same thing we did last time, that's why I'm going a bit quicker. X is subtract, this is the minimum, the value is the spline parameter length is the value. See, when I messed it up. Well, this thing is the maximum, and it is also what goes into here. Alright, and then the z value, which we saved it for later, this is for the rotation, will be what we plug into this maximum. Once again, this goes through a power node, something like 4, and the only difference here is that we're not going to add to the rotation, we're going to subtract from it, because we want it to decrease as we go out towards the end of the spline. So subtract, plug this in here, and now if I just set the push to 0 so that you can see this a little bit better, I should be able to adjust our unravel. There it is. So now we're unraveling as much as we need to. If I also add the push to this, we can now see, yeah, so now we can unravel and it just looks better. You can of course play with this exponent to get a slightly different result, slightly more smooth unravel I suppose, but this is pretty much going to be it for now. And of course if we change the length we can see the whole thing in action. Alright, so this is done. We got the unravel, we got the curve itself. Next let's talk about a little bit of performance. This can get pretty heavy, I won't lie to you, there's a lot of geometry here, and if you work with bigger curves it's really gonna start to stutter. So I'm just gonna give you a little trick to change the resolution. So you have this viewer node, viewport node, which returns the value of 1 if we're in the viewport and 0 if we're rendering. We're going to plug this through a switch node, which we're going to set to float as soon as I find it. And if the value is, and we're going to plug the viewport to the switch. Whenever the value is true, we want to use the set value for the resolution, for example over here. But whenever it is false, we want to use a really small resolution, something 001. So whenever we're rendering with a very high resolution. And this is what's going to go into the resample curve. Nothing's going to change visually, but if we render this out, it will render with more resolution, technically with whatever we set over here. So I'm not going to show you that because I have to set up a whole lighting and render scene. But yeah, this is a hot tip for performance. Because basically now you can set the resolution to something high, 0.1, and now if you want to make it much smoother, you can get a lot more geometry going. Because remember, this is a curve. You can at any point take it, move it around, just make it as big as we want. It's all dynamic. You can also add another curve to it. Let me just change the spline exacting a bit funny at the end. There we go. You can add more curves by simply going to this draw tool on the side. And it's all going to work. The length parameter is going to work for all of them. Okay, just do all that. So yeah, this is a hot tip for performance. Now next we're going to talk about the UVs. So the UVs are a bit tricky, if I have to be honest. There's a bit of a catch here. To do the UVs, I'm going to disable this by setting this value to 0. It would be nice to have a control for the unravel on the tier, on the next tier, because if I just show you right here, I increase the unravel, and I bring back the tier 3s, you're not going to. I also need to change the resolution back to something smaller. We're going to see that tier 3s are not unraveling. For that, just another control, tier 3, unravel, vector, plug that in, set it to the same that is over here, I guess. Roughly the same. And now we can play with this. Yeah, again, pretty cool effect. As we're moving this out, you can see they're stuttering a bit because my resolution is low. I hope that's fine. Let me try to reduce that. Yeah, now it's way smoother. Okay, so next we want to handle the UV situation. To do that, I'm going to collapse all of these, the curve to mesh and the curve circle, into a group, just for convenience. And this group is going to have an input for resolution. This is the resolution of the geometry, so it would be an integer. And you might want to give a separate control from that. So you have a resolution group input, just add another one called geo resolution, for example. Because this is the curve resolution. Maybe you can specify that. Curve resolution, geo resolution, should be an integer. Plug that in. As soon as I can find the geo resolution. The next input would be the radius, which would be a plot. And actually, yeah, maybe only 2 inputs. There we go. And then we want to talk about how we're going to get the UVs. Well, what we're going to use is the capture attribute once again to embed properties into the geometry, and what we're going to use is the spline parameter. Spline parameters factor. So by default, the factor, since we have a curved circle, this is my curved circle, is again 0, 1 on the last points. If it has how many points right now? 8, so 1, 2, 3, 4, 5, 6, 7, 8, right? 7, yeah, one more. The problem is that once we do this, in fact, I probably just have to show you. I'll show you in a bit. First, this is going to help us capture the U, but we also want the V. To get the V, it would be a capture attribute over here on the incoming spline, and this time we'll be using length. Okay, so what these two things give are of course floats, and we're going to want to collapse these floats into a combined XYZ. This is going to be our U, this is going to be our V, and this vector we have to output over here, and we're going to call this UVs because that's what these are. At this point you're almost good to go. What we also need to do is in our modifier tab at the very bottom, output attributes. We also need to connect this. We're going to call this node Solidify. the node that gives us geometry, because that's kind of what it does. Plug it into here. In the output attributes inside the modifiers tab, we'll set this to UVs as well. And now I will go into the Solidify also needs to add the material, because currently this geometry has no material. You need to want to set that to set, give it a material basically, and we're gonna want to plug this material into this node as well. So add a material, which is the material we're going to give to our geometry, and we're going to plug that in as soon as I fetch a group input right into here, and want to connect this to our main group. In other words, it's going to need a material node. I'll put it at the top, just makes sense to me. Got this material, plug this in, and now we have a material here. Next I'm going to actually create the material. I'll go into my shading layout, or we're going to look different for you. Don't worry, just click the new button up here. Once you're in the shader editor, you're going to get this. I'm going to call this rope, the rope material, and inside my modifiers tab I will add this into the field we created, rope. I will go into the viewport shading mode so we can see the result, and to bring the attribute you just got, we need to go into an attribute node, set this to UVs, because that's what we named it down here. This is important to get the name right. And I'm going to plug this into a wave texture. Plug the vector into the vector of the wave texture, and just so we can preview the results quickly, I will plug the color into the surface. And now you can see we have more lines. It looks like we added more resolution. This is because of the wave texture. Looks like we subdivide more without actually subdividing. And the first issue we're going to notice is this bunching up over here. So it's actually happening. If I go back into the geo nodes, into the Solidify, what we have over here, let me enable shading view, is we have values all the way from 0, maybe not drawn, there we go. Wow, that is a lot of resolution, but yeah, 0 to 1. So it's interpolating appropriately the UVs in this direction, but it's also doing it like this. It thinks it's 0 to 1 here, so it's bunching all of this up in this area. So that is because we're capturing a curved circle. Basically, we're not using UVs, we're sort of cheating, and we're using per vertex embedded information. So the closest thing to a fix that I have figured out for this is to, instead of using a curved circle, because let me hop out of this node, just go into the output group. Temporarily I'm going to disable this output. I'm going to delete this. So just to illustrate the point, if I get a curved circle, if I set this to 8, radius to like 0.1 for example, the issue is that we have basically no overlapping vertices. We can fix this with a mesh line, or rather a curve, what is it, spiral, curve spiral. So the curve spiral gives us, unsurprisingly, a big spiral. If we change the start and end radius to the same thing, and then if we change the height to 0 and change the resolution to 8, we get basically the same thing. If I connect them up with a joint geometry, just so we can tell these two apart, maybe change the radius a little bit. Yeah, we get the same thing, except in the first one we have two vertices at the top, where the first one we have only one. I can illustrate this as I change the height. Yes, you also need to set rotation to 1. You can see that once we collapse these, there's two vertices here, right? So what you end up with is a value of, technically this is what you get, but these are not connected, so you have value of 0 here and 1 here, and these are overlapping, and that will make it look as if you have the appropriate UVs. So let's do that inside our actual Solidify group. So again, instead of using a curved circle, we go spiral, we plug that in, We change the resolution. Well, technically we want the resolution to be controlled by the group input. So do we want the radius and start radius, height 0, rotation 1. Oh, and you also want to click reverse, because otherwise the normals are flipped. I don't know why, just make sure reverse is on. And with all of this done, we'll notice that there is nothing happening here. What's up with that? Where? Here it is. I forgot to give it resolution. Yeah, that's probably bad. And we're gonna want to have control for the resolution on the outside. So we're going to give this, technically this will be the resolution of the tier 3, so I guess we can name this tier 3 radius. But to separate it from the other radius, it will be 0 radius, where the first one is the spline radius. Set this to a float, connect this up, you give it some value, radius, G radius, and, oh, because the resolution isn't set, right? Geo resolution is to be. Damn, I really need to remember to just set these up. Alright, so yeah, this is what you need. Rotation, add something close, otherwise you get normal artifacts later on. Yeah, see, if I set it to 1 here, the normals get totally fucked up. We don't want this to be overlapping that tightly. Set that, and the set spline cyclic. It doesn't fix the issue, but it sort of smooths it over a little bit more. But this is as close as to a fix that I can get. Well, aside from playing around with the shader, where you would probably give this some sort of color, and you can use this wave texture to plug this into a bump. Basically, we're using this size as a bump, plug this into normal. Problem is that they're very high now. This is like a meter away. Realistically, they're more like this amount. That would smoothen this out a little bit better, make it more realistic. And you can not plug the color in directly. You can pick whatever color you want, and instead use the color, or rather the factor, to add something like an ambient fusion. So set this to multiply. Then we have the darkness at the top, and at the bottom is your color of choice, I suppose. Maybe these need to be flipped, or you can just set it to mix. That should also be. Yeah, there we go. So it looks like you have some ambient occlusion. And the best part about this is between the attribute and wave texture, if you add a mapping, you can then rotate along the X, I believe. No, is it the Y? Is it the Z? Yeah, as you rotate on the Z, you see we are getting the lines, the pseudo curves, to go diagonal. Then over here you can simply change the scale to make them finer. In this case, increase the scale, and now we have some really nice fake fake detail here. Of course, no rope is really blue, it's more like reddish, I guess. Much more muted colors. And to change the strength of this darkness, we just need to change this a little bit so it's not as dark. But yeah, we're getting there. You can play around with it a bit more. You can probably plug in a color ramp here to really get some control over this factor. I would probably sharpen it by bringing this the opposite direction. Yeah, there it is. Really go crazy here. One more thing we can do to bump up the realism is add a bit of stray fibers. So how would we do that? We do that, where was it? After the joint geometry. Actually, maybe right before it. It really depends. We'll see what works best. The idea is we're going to take the second spline, okay, this second spline, and we're going to use its points to instance on. So instance on points, take this. I guess we're going to want to realize these instances right afterwards. And I would probably group this up right now before it gets too messy. Call this fibers. Alright, so we have our points. What are we going to instance on these? We're going to do Quadratic Bezier. If I plug this into here, and probably lower the resolution to 8. So we have Quadratic Bezier. They should be showing up now. They're not because I didn't actually connect the output. Okay. and I can plug this into the joint geometry, in which case they'll probably be way too thick. Yeah. These need to have their own Solidify because they need to be smaller. So I would just duplicate this Solidify, plug this into here, and then before outputting this, we hit it with the joint geometry. Alright, that will allow us to set a resolution, something very small, no more than 4, and a radius. Yeah, so they're all very big still. Probably shouldn't be a negative radius. You can clamp the radius. Alright, so there are way too many. To reduce that, we will just do a random value. We'll set this to Boolean, plug this in here, and the probability is basically how much we reduce them. Alright, so now we have more. And the seed, so if we don't keep the seed constant, whenever we cut this route, they're gonna start shifting. So we want the seed to be related to some number. In this case, we want to use the Spline Parameter index into the ID. And now as we chop this off, there's staying put. Alright, so that's great. This value, you can plug this into some sort of control in the modifiers to change the amount of fibers. I won't do that right now because this tutorial is already way too long. So if we use a Quadratic Bezier, you can actually change the start to 0, change the end to 1, and then change the y to 0.5, and then whenever you shift the y, you're actually changing how these are curving. You can really reduce the resolution of this because they're going to be so small. We need to instance them in a special way so that they're rotated towards the normal. To do that, we'll do align euler to vector. The vector is going to be the normal. We're going to be aligning with the normal. If I plug this in, we want the z because we set it up so that they're pointing upwards with the z over here. Plug this into rotation, and now they're basically always facing the z of our curve. Problem is we want to add some randomness to that, so I'm going to rotate this normal vector with a vector rotate, where the angle is going to be a random value that's going to be between 0 and 2 pi, because that would be in radians, 360 degrees. And again, we want to plug in the spline index into the ID, so that will give us their way to go right now. We also want some randomness for the size. For the actual Solidify, the actual diameter, I mean radius of them, we control it from this node. So it has to be really tiny, 0.5 probably. It's going to look like hairs. And for the actual size, we want to change this scale value over here. Of course, we want to use randomness, so vector, so a random value, which is a vector. We don't want to change the x and y, so I'll keep those at 1 for the minimal maximum. And we want to just play with this value, where we change the maximum and the minimum. Okay, so this is a bit too curvy right now. I would say change the y over here to make them less curvy. Something like this looks decent to me. And we also want to give them some random rotation, although they are all facing down right now for some reason. I don't know why they're doing that. Oh yeah, I need to actually be rotating this normal around the tangent. So go ahead and plug in a curved tangent into the axis. There we go. So now they're randomly dispersed. We can actually just get a vector rotate and plug a random value into the axis. Yep. So I guess another random value into here. To get every axis possible, first has to be -1, next has to be 1. And if we increase the angle, we see they're going all over the place now. And what we want to do is probably another randomize here, set to only pi because we don't want them to rotate 360 degrees away. This case scenario. And now we have this, which I think is pretty close to a believable result. Of course, play around with these settings. We're getting a lot of ropes. To increase the amount, simply there we go. It's not bad. And of course, they shouldn't be moving whenever. Well, they're moving because I used another random value which I did not connect with my spline index. Where else did I use a random value? Over here. All the random values need to have the ID connected with the index. There we go. Now there's the input as I am changing the unravel. And I guess this should also stay put if I change the curve itself. Yeah, see, I'm changing the size of the curve, but it's all staying put. I have magnet on. There we go. So yeah, I think this looks pretty great. Honestly, I think it looks like believable rope. These don't have material, that's why I forgot to give them. Since I'm using a separate node to solidify them, I will have to feed them the material separately, like that. Now they should look with the same color, roughly. They're looking a bit dark because they don't have UVs the same way the other things do. You probably want to give a separate material for them because they technically aren't going to have UVs. We can do that, just copy this material with the little paper icon, call this fibers, and just set this up from over here without the node. You can plug it in, but this probably does not work. And then all we need to do is remove the whole UV thing and just keep the color, because that's all I care about, just as the basic color. Okay. And now, any second now, oh, that's not the base color. There we go. And I think that looks pretty believable for rope, but please do play around with it. So yeah, if you did enjoy this tutorial, do let me know. Whoa, there it goes. Do let me know, because I can also make a tutorial on water. I think that'd be pretty cool, water splashes, or just animate water along a path. That'd be pretty cool. Another thing, I can make a tree, if you want to see a tree. But I do warn you, the tree is probably going to be as complex as this one. Yeah, and if you have any other ideas, or if I get any other ideas, I'll make sure to make a video on that. So subscribe for more. Yeah.